Hi, Miss Albert. It's Daniel. I hope you're doing well. This is my Unit 4 assignment, and it consists of 3 questions that I've come up with. And yeah, let's get started. Okay, so a mass of 8 kilograms is suspended by 2 strings. The strings are 38 centimeters and 48 centimeters long from 2 points that are 80 centimeters apart and at the same level. Determine the tension in each of the strings. So we've got quite a lot of information here. We've got 8 kilograms, which we can later use to calculate our force of gravity. We've got the length of one string, which is 38 centimeters, the length of another string, which is 48 centimeters, and the length between the 2 strings, which is 80 centimeters. So let's draw that. Okay, so first let's start with position diagram. Okay, so first we've got the 2 points. One can be here and the other can go right here. And between them, they are 80 centimeters apart. Next, we can draw the length or both of the strings. So, okay, so one string is 48 centimeters long. We'll make this one the 48 centimeter one. And then the other one is 38 centimeters long. I can make that 8 a little bit better. Okay, so then after, we've also got a force of gravity going down because of mass. So we'll have the mass right here, and the force of gravity will be going straight down. So since the force of gravity is going straight down, our 2 forces of tension will be acting against that, so we'll have our arrows going upwards. Okay, so that's all the information we need for now. We also have our 8 kilograms, which we can later use for FG. So now let's also label these lengths. So we can have 48 centimeters as length 1. I'll use capital L, just so instead of lowercase. Okay, and then our 38 centimeters will be L2. And then 80 centimeters can be L3. So our goal with the lengths is to calculate both of these angles, which we can later use to calculate the force of tension. So I'll call this angle theta 2, and then this one can be theta 1, just so L1 is opposite with theta 1 and L2 is opposite with theta 2. Okay, so the first step is so since we've got this length and this angle and this length and this length, we can actually use cosine law to calculate the 2 thetas, or the 2 angles. So cosine law is c squared is equal to a squared plus b squared minus 2ab cos theta. So that's what it is. Now we kind of have to use the variables I used. So for c squared, let's use L1 since we want to calculate theta 1. So I'll do L1 to the power of 2 is equal to, I'll do L3 for A and L2 for B. So minus 2 times, and then L3 cos theta 1. Okay, so now that's our equation, but now we've got isolate for theta. So we can start by subtracting L3 and L2 over. So I'll do that. Is equal to -2 times L3 Okay, so now we've moved over the L3 and L2. Next we can divide the whole thing, so we isolate for cos theta, so we divide -2 times L3 times L2 to the other side. To the power of 2. Okay, and then I'll add the vectors. And then we're going to divide the whole thing by -2 times L3 to the power of 2 minus, or not to the power of 2, just L3 times L2. And we're gonna add the vectors. Okay, and that's equal to cos theta 1. Okay, so now all we've got to do is put this in brackets and then inverse cos, so we get the angle of theta. So let's do that. So I'll move theta to this side so we can solve for it after. Divided by -2, and I'll add these vectors here. Alright, okay, so now that we've got our formula, which we'll be using to calculate theta 1, we're going to plug in all the values. Let me just check the camera. Okay, so theta 1 will equal, I'll make it go one line lower. Theta 1 is equal to cos inverse 1. So L1 is 48 to the power of 2 minus L3, which is 80 to the power of 2, and minus L2, which is 38, and to the power of 2. Okay, then after we will be dividing it by -2 times L3, which is 80, times L2, which is 38. And close the bracket. Okay, so now I'll plug it in. So we've got inverse cos 48 to the power of 2 minus 80 to the power of 2 minus 38 to the power of 2 over -2, 80, 38. And you've got 24 24.33 degrees. Okay, so I'll write that down. So since we're solving for theta 1 here, we'll add the angle symbol as well. So theta 1 will be equal to 24.33 degrees. Okay, so now that we've got that down, to calculate theta 2, we can actually just use sine law. So it'll be sine theta 1 over, so since we're using sine theta 1, its opposite would be L1. So L1 is equal to sine theta 2 and its opposite, which is L2. Okay, so now we have to isolate for theta 2. So we can do that by first multiplying L2 up here. So let's do that. Divided by L1. Okay, and then that's equal to sine theta 2. Okay, now we've got to isolate for this theta 2. So we'll actually bring the theta 2 to this side so we can, because just having what you're solving for on this side is usually how we do it in math. Okay, so is equal to sine inverse 1 sine theta 1 and then L2 and L1. Okay, and we'll also add the angle symbol here. Next, we're going to plug in all of these values. So I'll do that right here. Let me see if you can see that. Okay. So we're going to do that. Theta 2 is equal to sine inverse 1. Okay, so sine, and now we know theta 1 is 24.33 degrees. 24.33 degrees. And that will be multiplied by, let me just make this curve more clear. That'll be multiplied by L2, and L2 is 38 centimeters. Next, we're going to divide the whole thing by, we're going to be dividing the whole thing by L1, which is 48 centimeters. Okay, so now we have theta 2 is equal to, so I've already calculated this before. So instead of plugging it in, I'm just gonna, I have it here, so it's 19.04 degrees. Okay, so now we've got both of these angles, which is really what we needed at the most. So now we can redraw our position diagram, and then after draw a vector diagram, where we're going to be solving for the forces of tension rather than using the lengths to find the angles. Okay. Or actually, miss, I'll pause the recording for a second and see if you could see this picture.